definition you may or may not have seen before about even and odd functions. So a function y is equal to f of x is an even function of x if f of minus x is equal to f of x, and it's an odd function of x if f of negative x is equal to negative f of x. And so first off, I should comment on even and odd. So this comes from the fact that kind of our, prototypical examples of even and odd functions are even and odd powers of x. So for example, if f of x is equal to x squared, f of negative x is equal to negative x squared, and so that would be minus 1 squared. I'm belaboring the point here to emphasize, look, we get back to f of x. F of x, if instead we think about x cubed, f of negative x would be minus x quantity cubed is minus 1 cubed times x cubed. Minus 1 cubed would be negative x cubed, and that's negative f of x. So we see here, if f of x is x squared, f of negative x is equal to f of x. It's an even function. If we take a look at f of x is x cubed, f of negative x is negative f of x. It's odd. So this is even, this is odd. And in fact, if we replace these with any even or odd powers of x, you'd see the same phenomenon. And so graphically, what is going on with even and odd functions? So here is an even function. Here is an odd function. So they both have symmetry. So an even function has symmetry around the y-axis that we can just kind of fold. If we fold this in half right here, this side has to look like this side. And odd functions, they have rotational symmetry. If we were to take this and rotate it by 180 degrees, that should look the same as that. Okay, so you might be wondering, what the heck am I talking about? What does this have to do with calculus 2? Well, as it turns out, there's kind of slick things that you can do when you're integrating even or odd functions. And so let's think about this. Let's suppose that I'm integrating from minus 3 to 3 x squared dx. So let me draw the picture here. It's going to be a typical even function. I'm going to make this more general in just a second. So definite integrals, so let me just put some lines here, minus 3 to 3. Remember, definite integrals are areas under curves. So I'm trying to find the area under this curve, but by symmetry, the area under here has to equal the area under here. And so if I want to, I could just compute this by computing the integral from 0 to 3 of x squared dx and multiply that by 2. And so for any even function, so let me write here, let me say e of x, if e of x is an even function, so don't confuse this with the exponential function. This isn't e is 2.718. This is just a letter to indicate this is just like f is an even function. The integral from minus a to a of e of x dx is equal to twice the integral from 0 to a of e of x dx. Okay, what about an odd function? If I were to integrate from, let's say, minus 2 to 2 of x cubed dx, well, let's draw the picture. So x cubed looks like that, and looks like that. So there's minus 2, there's plus 2. And so it's the area under curves, except it's a signed area. So it's plus this area and minus that area. These two should be the same area, and so they're going to cancel each other out. And so this answer should be 0. And we can quickly verify that. So if we actually evaluate this integral, x to the 4th divided by 4, plug in minus 2 to 2, and that will give us 2 to the 4th divided by 4 minus 2 to the 4th divided by 4. And so those are both 16 over 4 minus 16 over 4. And sure enough, that's 0. And so if let me make a fancy scripty O here for an odd function. If O of x is an odd function, then if I'm doing an integral of an odd function on any integral of an odd function any interval from minus a to a, the answer is 0 without doing any work whatsoever. And so this is a very, very nice trick. It can allow you to evaluate some integrals without doing any work really whatsoever, as long as you know something is odd. More things just about even and odd. So x squared, x to the 4th, x to the 6th. Any constant function would be an even function. Also, cosine x is an even function. And if we combine these together in any way, that doesn't stop at x to the 6th. It keeps going. If we combine these together anyway, it still would be an even function. So, for instance, if we were to have x squared minus x to the 4th divided by 7 plus cosine of x divided by 2 minus x to the 72 plus 6, this is an even function. For odd functions, so x cubed, x to the 5th, these are all odd functions. Sine of x is an odd function. Also, negative exponents work as well for even odd functions, although then you can't integrate through 0, which gives you a bit of trouble there. And one last little point to make is that just as an even function, an even number times an odd number is even function times an even number times an odd number is odd. So even function times an odd function is an odd function, and an odd function times an even function is, that was supposed to be odd function times an odd function is an even function. So if I were to say I have x cubed sine of x, odd function times odd function, this is actually even. So just a little bit of information, slick ways to evaluate integrals.